Hey everybody, we're looking into the last couple days we've been talking about a little bit of our functions and the different properties of functions. And we talked about there's 5 different types of functions. We discussed their domain, their range, as well as just kind of their general form. And then today we started dealing with how to move those things around. So I just kind of want to give you a little review or your first look at the different functions and then how to move those things around, or at least the basics for that. We won't get into the practice maybe until tomorrow or the next couple days, okay? So first one we've dealt with a bunch, a linear function just as a straight line. It's parent function, and all 5 of these are considered the parent function. The parent function is just a fancy way to say it's the beginning or most basic version of that graph. We'll talk about when we move those things around. That's kind of like the baby of this parent. It's the same idea. It looks similar to it, but it's not the exact same. Okay, so the parent function is the most basic version of this function. So if we say, hey, let's go back to the parent function, or how does it compare to the parent function? These are the graphs we're talking about. Okay, so the parent function for linear functions is just y equals x. If we think about graphing this, it's normally we think, okay, well this is 1 over 1, and there's no y-intercept, so it's 0. So that's kind of the idea of what that would look like for our parent function. The technical way is just y equals x. We talked about domain and range. Domain is all the x values that are possible for this graph, and all of the y values is our range. So for our domain, if I look at this graph, it's going on forever in both directions. So our domain is going to be all real numbers because there's no x value that this is not going to hit or be a part of our graph. So the way we write that is just x equals all real numbers. You can put 2 bars on the left side of the R, stands for all real numbers. If you want to write out all reals, that's totally fine as well. For my range, again, that's our y values up and down. It's going on forever in both directions, up and down, so it'll hit every single y value. So our range here is also all real numbers. Make sure a range, since it's always talking about y's, you should have a y written next to it. Okay, and that's our linear function. General shape is a straight line. Parent function y equals x. Domain is all real numbers. Range is all real numbers. Okay. Then if I look at absolute value, so our absolute value graph looks like a V. Okay. This one's the way I kind of remember it, or the way you can remember it. It's got a V in its actual name. None of the rest of these have a V within them. So absolute value has a V, so it's going to look just like a V. Okay. The parent function is y equals x as well, but it has the absolute value bars around that. So that's why it is different than our linear function. For this one, if I look at my domain, again, is it going to miss any x values? Well, since it's going to gradually get wider and wider, it's going to have an x value no matter where you are on this graph, and it's never going to stop getting wider. So this thing is also x equals all real numbers. Okay, it's never going to stop going left or right. It's going to hit every x value possible. Okay, for my range though, this is the first one. So our linear function had all real numbers. This one we do have a constraint or spot where our graph stops. Okay, our range, and normally we have kind of this set up. It's something like this. We fill in the blank with the numbers. Okay, and that's our normal domain and range setup. So we'd say, well, what's the minimum? What's the lowest this thing could possibly go? So if I look at this graph for our parent function, the lowest it goes is right here at 0. That's the lowest y value. So I'm going to put a 0 over here. Okay. As far as our graph going up or down, we had a limit on the bottom, didn't go past 0 down, but up, this thing goes on forever. It's got those arrows telling us it's never going to stop going up. So if it's going to go up forever, this is infinity. You'll see some people put an infinity sign over there. For in here, it's fine to just leave it like this, because it's just saying y is greater than or equal to 0, or 0 is less than or equal to y. That covers everything that we need to for our range. Okay, so this would be our complete domain and range for absolute values. Okay, again, the only restriction is y is going to be bigger than 0. Okay, for square roots, again, square root of x is our parent function, our base function. It kind of has just this little curve. This one looks like it's half of pretty much all the rest of ours. It's just got a little hook. That's it. Okay. It kind of looks a little bit like its own square root symbol. That's how I kind of remember it. Is this one has that little curve. Kind of looks like it could be this if you did a sloppy square root sign. Okay. Our domain. So again, our normal setup, if it's not all real numbers, is like this, where we're filling in our blanks. So if I think about my minimum, so what's the furthest to the left that our x actually goes? So our x values stop right here at 0. There's no negatives at all. So I'm going to say 0 is my minimum for my x value. For my maximum, or as the furthest to the right it possibly goes, for this one it goes on forever. Again, it's got the arrow saying it's going on forever, so it's going to hit every x value to the right of our 0. So because of that, again, I don't need to put the infinity there. I can just put that x is greater than or equal to 0. Okay? And if you're a person who's like, hey, if you want to put, I'm going to put or, you could put x is greater than or equal to 0 this way. I just like to keep it in that same format because when we get to our domains later and we deal with what's called piecewise functions, it's helpful to have it in that format of the x being in the middle. So if you'd rather write it like this right now, that's fine, but when we get to our piecewise functions, that's why I'm showing it to you in this format. Okay. So our range then, our range as far as how far up and down, again, if I go through and be like, all right, here's my basic setup. Minimum, the lowest this thing's going to go is 0 again. It doesn't go past that 0. That's the lowest it's going to go, so I'm going to put a 0 here. As far as going up, even though it kind of looks like it flattens out, this thing gradually is going to go up forever and ever, so it will eventually hit every possible y value. So again, this one's going to be towards infinity and beyond. There's nothing over there. Okay, so I can leave that blank again. Y just has to be bigger than that 0. So our constraints is the domain is got to be bigger than 0. Our x value has to be bigger than 0. Our y value has got to be bigger than 0. That's all we have for this one. Okay. Got our last two. It's a lot of information. We kind of went through this for a full day, so it's a lot of information real quick. Our quadratic. So our quadratic is anything that has the power of 2. Okay, so we've dealt with those a little bit in algebra. Anything to the power of the 2 gives you that U-shaped parabola, the word that's really fun / difficult to say correctly. But parabola is what we get here with our quadratics. Again, we know it's a quadratic. We've got that exponent of 2. This is the parent function again, the most basic function of a quadratic. Okay. For our domain, it does go both directions, left and right, forever and ever. They got the arrows going on. So this one is going to be x equals all real numbers as well. For our range, just like our absolute value, the lowest this thing ever goes is right at that 0. So again, if I'm filling this out, I have 0 less than or equal to y. It goes on forever up, so there is no piece to fill in over on the right side as far as our maximum. So I just have 0 is less than or equal to y, or y is greater than or equal to 0. So our only constraint, got to be bigger than 0 for our y values. Okay. Then for cubic, our cubic looks like a little S, kind of turned sideways, a little squiggly guy. It's kind of like if I took this parabola and I broke this side on accident, now it's hanging down. That's what our cubic looks like. A cubic is anything with the power of 3. So again, quadratic is power of 2, cubic, power of 3. So when we're looking at our cubics, these ones are kind of like our linear function that got squiggled out a little bit. It's going to have the same domain because it goes forever in both directions, so it's going to also be our x equals all real numbers. Our range goes up and goes down forever and ever, so it's eventually going to hit every single y value. So this one's also going to be y equals all real numbers. Okay. Again, these are the parent functions. This is the most basic of each of these types of functions. Linear, absolute value, square root, quadratic, and cubic. This is just their general forms and their domain and range. Okay. Transformations is going to deal with in geometry. We talked about like rotation, reflection, translation, those type of things. The transformations are similar here. This is how we're going to move these things around. Okay. So these values, this is the general format. So this is one that I had everybody write down. F of x, the function of x. We've got our a parentheses x minus h parentheses squared plus k. That is the general kind of format. Although you don't see that all the time from every single one of these, that's how I would make these things move around. Okay. So as far as our a values, when our a value is greater than 1, okay, when our a value is greater than 1, so this number right here, I think of it like in our graph over here for our linear function, this one that we've most dealt with. If you put like y equals 3x, what happens is now this thing gets a little bit steeper. Okay, it gets a little bit more up and down. So what I put over here, and I'm looking because I wrote this down as far as how I want to say this, it stretches it vertically. Or if you want to put, it makes it skinnier. Okay? So if a is bigger than 1, when this value, whatever that value might be, is bigger than 1, it stretches your graph vertically, makes it a little bit skinnier. When it is less than, so in between, basically our a value is between 0 and 1, a half, 3/4, something like that, 0.25. Be careful because if you have a fraction that might be like 8/5, 8/5 is bigger than 1, so that would fall into this category. So when you're dealing with a fraction, make sure it is something that is in between 0 and 1. If it's between those two, what you're going to end up with is it's going to stretch it horizontally or compress it. Presses the graph. And what that looks like is it's a little bit fatter or wider. Okay. So again, up here, if we're using our linear function as an example, if I put y equals 1/2 x, now it's going to be kind of going over here a little bit less vertically. It's going to be a little bit wider instead. Okay. Our last one is if we have something at a value where it's less than 0. If it's less than 0, any type of negative number, doesn't matter what it is, but if it's a negative number, what happens is it flips our graph. Okay, so it flips our graph. I'm going to put over the x-axis. So essentially, if I'm looking at the quadratic, it's the easiest one to see. It would take this u and flip it over. It would take our absolute value v, flip it over. Square root flips that thing over. So essentially, it just flips it over that x-axis. So anytime you have an a value that's less than 0, it flips the graph over the x-axis. Okay? We got 4 things left. We have our h and our k that we need to talk about. Okay? Our h, when it is greater than 0, what happens is it moves our whole graph over to the right. Okay? So when it's greater than 0, moves graph to the right. Okay? What this looks like, and this is the confusing one, this is what people have mistakes on the most. So what it looks like, so I'm going to put an example. What it looks like is inside my parentheses, I'll have x minus 5. Our formula here says x minus a number. So if I plugged in a positive 5 into there, it would look like x minus 5. So that's actually going to move my whole graph to the right. Okay. For our h less than 0, you probably can guess, this is going to move it to the left. So this one says moves to the left. And what that thing looks like would be x plus, and I'm just going to use 5 again, 5. The reason for that is x or h value less than 0, so if I had a negative 5, if I put that into my formula, it would be x minus, and I plugged in negative 5, minus a negative, change it to positive, so that's where we get the x plus 5. Okay? So when you see this format, your graph is moving to the left. The last one is our k. K is probably the easier one because we're used to seeing it with our y equals mx plus b. We have it as our b there. But our k essentially tells us our up and down. So if our k is greater than 0, it moves the graph up. And if it's less than 0, it moves down. Okay. Again, this is a whole lot of information kind of thrown at you at once. This is probably one of my longest video yet, but want to get you the ideas of our different functions and then also how we can move those around. We'll practice moving them around a little bit more and kind of looking at graphs and how they moved in the next couple of days. This at least gives you a good idea of our 5 functions: linear, absolute value, square root, quadratic, and cubic, what their parent functions look like, what they look like initially before they're moved around, and then how we're going to go about moving these things around. Okay. Again, if you have any questions, feel free to shoot me an email. Looking forward to seeing you guys soon.